Okay, so we looked at graphing sine and cosine functions, right? So, see if I can get a line here. So basically, a rough sketch of our sine function, right? We start at the origin and we go to 2 pi, right? So we know that y equals sine x has an amplitude of what? What's the amplitude? 1. It has a period of 2 pi, okay? And cosine is the same way. Okay, I always have to do the cosine in increments here. Okay, so cosine has the same thing, an amplitude of 1 and a period of 2 pi. Those are the only two trig functions that I'm going to make you graph. However, I do want you to be able to recognize the other 4 trig functions. So if we look at tangent, okay, first off, if we go back to our unit circle, right, tangent is y over x. So there's 2 places from 0 to 2 pi where tangent is undefined. And where would that be? When x is 0. Where's x 0? Right here at 90 and down here. Or we can say at pi over 2 and 3 pi over 2. Tangent is going to be undefined there. So if we go from 0 to 2 pi, let's see, here's pi over 2, and here is 3 pi over 2. Because the tangent is undefined there, we have what we call a vertical asymptote. So we have this invisible line here that the tangent function does not cross, okay? So let's just look at values of tangent on that unit circle, okay? Just look at it a little more carefully. So we know it's undefined here and here, okay? Bless you. So if we look at our y over x's, we're going to get 1/2 over root 3 over 2. And I'm not going to worry about simplifying it right now, okay? That's at 30 degrees. At 45 degrees, we get 1. At 60 degrees, we get root 3 over 2 over 1/2, right? Just doing y over x. Everybody following me? Okay. On the other side, we're going to get negative root 3 over 2 over 1/2. Oops, I'm sorry. Yeah, it's still negative. We get negative 1. We get negative 1/2 over root 3 over 2. Down here, I get a negative over negative, so I basically get the same value as this one. Right here, I get the same as this because it's negative over negative. And then here, I get the same, okay? So basically, after I went past the 180 degrees, or after I went past pi, I start getting the same values here. Down in this quadrant, what happens? I get the same as this quadrant, right? So what do you think the period of our tangent function is going to be? Remember, for sine, it takes a full time around the circle, right? Look at the unit circle. It takes a full time around the circle before we start repeating everything. 180, yeah. So tangent, it's going to be tangent is going to have a period. Y equals tangent x has a period of pi. Okay. Okay. So when we graph the tangent function, tangent of 0 is 0. Okay, we're going to get this funny looking graph. It actually goes like this. Let me see if I can make another mark here. This is negative pi over 2. Okay, it's going to cross through 0, 0. But it's going to go like this. Kind of almost looks like a cubic function. Okay, that's my tangent function. And it's going to repeat that as we go. Okay, so that's what your tangent function looks like. The tangent function is most notable because we'll see that it does not, or it's undefined at pi over 2 and 3 pi over 2 and negative pi over 2. Okay. So what I want you to know about a tangent function, first off, it's period. Instead of 2 pi, it's pi, right? Because it repeats itself every pi unit. And its general shape. So I want you to be able to recognize that that is tangent. Okay. And we're not gonna do any weird transformations or anything. Just a basic tangent function. Okay. Okay. Let's look at a cotangent function. Just see if I can copy this. And duplicate. There we go. Okay. So what's cotangent? X over y, right? Cotangent is x over y. So where is that going to be undefined? Where is cotangent going to be undefined? At pi and 2 pi and 0, right? So here we're going to take this. It's undefined at pi, 2 pi, and at 0. Okay. Okay, so cotangent is going to go like this. Yeah, make sure. Okay, it's going the other direction like that. There's your cotangent function. What's the period of a cotangent function? The period. How long does it take to repeat itself? Pi. The period is pi. Okay. Okay, look at the difference between tangent and cotangent. For one thing, the vertical asymptotes are different. Okay, where it's undefined is different. For tangent, it's at pi over 2, and then every pi units from there. Cotangent, it's at pi. You can also look at the zeros. Okay, tangent is going to be 0 at 0 and pi, or 180, and of course 2 pi. Cotangent is going to be 0 because cotangent is x over y. So we're looking to see where y is 0. So what did I just do? Yeah. So cotangent is going to be 0 when x is 0, which is pi over 2 and 3 pi over 2. Okay. Tangent is 0 when y is equal to 0, because a fraction is going to be 0 when the numerator is 0. So tangent is 0 when y is 0, which is right here. And right here, that's where y is 0. Cotangent is going to be 0 when the x is 0, and that's in these two spots. Okay, so those are two main things that you're going to notice are different, where it crosses the x-axis, and of course the asymptotes. And then, of course, we have the shape. But to be honest, sometimes you forget which direction it goes. In my mind, this is how I remember it, okay? And I know my mind is a little weird, right? This, excuse me, this curve kind of follows like a positive direction, right? When we go from left to right, we feel like it's positive. I think of the tangent as, I just think of it as a positive. Whereas the co's, I think of co's as almost negative. They're not really negative, but that's just how my mind translates them. Co's are like the opposites, they're the negatives. And this curve kind of follows that negative direction because it's going down as we go from left to right. Does that make sense? Okay, that's kind of how my mind processes it. Okay, let's look at secant and cosecant. Okay, I'm going to just graph that again.